Basic trigonometric facts. These basic trig facts I'm going to teach you here will help you when you're looking at doing graph transformations on trigonometric graphs, and will help you plot the trigonometric graphs. You also might find these facts useful if you're doing Mechanics 1 on various problems to do with forces on inclines, etc. So, if we look first here at a right angle triangle, which is an isosceles right angle triangle, meaning that the two remaining angles are both 45 degrees. If we were to find this longest side here, we could use Pythagoras' theorem, knowing that 1 squared plus 1 squared is equal to 2, so this length must be equal to the square root of 2. Knowing that fact, we can find the values for sine 45, cos 45 and tan 45. So if we take this angle here as being the angle we're using, then this side here will be the opposite, this one will be the adjacent, and this one is the hypotenuse. So remember that sine is equal to opposite over hypotenuse, so it's 1 over root 2. So the sine of 45 is equal to 1 over the square root of 2. We do cos of 45, that's adjacent over hypotenuse, that is exactly the same value as sine of 45. And finally, if we do tan of 45, you'll get opposite over adjacent, which is 1 over 1, which is 1. Now, some other useful facts will be to do with this equilateral triangle of sides 2. Now remember, in an equilateral triangle, each angle is the same and each angle represents 60 degrees. Well, if we split this equilateral triangle down the middle, we end up with two identical triangles. And it also means that now at the centre here we've got an angle of 90 degrees, and this angle here must be 30 as it's half of the original 60 degrees. So this angle here represents 30 degrees. We can also split this 2 up here for this base length into two sections, 1 and 1. And we can find this height here by using Pythagoras. Remember that this represents the hypotenuse, so that's 4 minus 1, and square rooted will be equal to root 3. So we can now use this triangle to identify sine 30, cos of 30 and tan of 30, and then we can also use this triangle to identify the values for sine of 60, cos of 60 and tan of 60. So if we look at sine first, sine of 30, so we're using the angle here, so opposite is going to be the 1 and the hypotenuse will be the 2, so 1 over 2. Cos of 30 is going to be equal to root 3, the adjacent, over 2, and tan of 30 is going to be equal to the opposite, which is 1, over the adjacent, which is 3. So that's 1 over root 3. Now, let's use exactly the same triangle, but this time to find sine of 30. So now we're looking at this angle, which makes this the opposite, and this is the hypotenuse. So that's root 3 over 2. The cos is going to be the adjacent, which is 1 over 2, and the tan is going to be the opposite, which is root 3 over 1, which is just root 3. So as I said, these trig diagrams here could be very useful when looking at plotting trigonometric graphs, when looking at doing graph transformation involving trigonometric graphs. A couple of other useful facts is you need to know the following. You need to know what sine of 0 is, sine of 90, sine of 180, sine of 270, and 360. And if you remember from GCSE, but the sine graph goes like this. It oscillates between 0 and 360, and the middle is in 180. And if you remember, it goes to a height of 1 and -1. So sine of 0 is equal to 0. The sine of 90 is 1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 is 0. Well, cos is very similar to the sine rule. However, this goes, instead of starting at 0, it starts at 1 and goes down to -1, and it goes in this shape between 0, 90, 270, and -1 is in the middle at 180 degrees. So 0 is going to be 1, 90 is equal to 0, 180 is equal to -1, 270 is equal to 0, and 360 is back up to 1. And those little facts can be very useful again for when you're plotting trigonometric graphs, which we have done here, and when we're looking at transforming trigonometric graphs.